Hi, and welcome to this video where we're going to explore our second binomial pattern. And you should have hopefully already watched the first pattern video where we explored an a plus b times the quantity a minus b pattern. In this video, we're going to explore the pattern where we take a binomial that is exactly the same and multiply it by itself. In effect, we are going to take a binomial and square it and see how this result occurs. So let's go ahead and take our area model to explore how this actually happens. So if I take my area model, I'm going to take a 2 by 2 grid because a plus b quantity squared is the same as a plus b times the quantity a plus b. So I'm going to use my area model to multiply this out. I'm going to take an a and a b, and I get a squared plus ab, because these are both positive, plus another ab plus a b squared. So if I collect these like terms, I'm going to have an a squared plus 2ab plus b squared, which you can see is the resulting pattern that we are going to start to use. So in this video, I'm going to do 3 examples, one that's pretty simple, one a little more complex, and then one that's a little more advanced. Okay, let's take a look at the first example we're going to do using this pattern. The first thing we need to do is make sure that our example fits the pattern a binomial squared, and it does. The second thing we're going to do is we're going to identify a and b in our example. If you look at this example, our first expression a is equal to y, and our second term in the binomial b is equal to 25. So first thing we're going to do is identify our a and b, and then we're going to use this pattern to get our result. So we're going to take our a and we're going to square it. So we have y squared plus 2 times a times b, so 2 times y times 25, plus our b squared, so that would be 25 squared. When we multiply this out, we get y squared plus 50y plus 625. You can see we've very quickly discovered what our binomial squared is. Now remember, when you square a binomial, and we're just going to kind of verify our result using our area model, this represents y plus 25 times itself. So it's really important that you do not square each term. That's the common mistake that people do and result in y squared plus 625. You need to make sure you remember that you are multiplying a binomial times itself. So if we're using the area model to justify our final result, we're going to rewrite this as y plus 25, and I'm just going to zip through this quickly for you. And as you can see, as I finish this up, we have y squared plus 25y plus 25y, which is 50y plus 625. So this pattern's a little bit different than the first pattern we discovered because these two middle terms don't cancel each other out. If you take one of the middle terms and double it, you get what your result would be if you collected the like terms. So you can see that our answer agrees with what we got using the shortcut. Here's the second example we're going to look at, and this one's a little bit more complex. Again, we're going to verify that our example looks like the pattern a binomial squared, and it is. It's 3m plus 13 quantity squared. So in our example, our a is going to be 3m, and our b is going to be 13. And when we follow this pattern, which is what the result is every time we square a binomial, we're going to take our a squared plus 2ab plus b squared, and we're going to plug in those expressions. So I'm going to have a 3m here, a 3m and a 13 here, and a 13 squared here. So when I square the 3, I get 9m squared plus 2 times 3 is 6, times 13 is 78. So when you do this, kind of think of it like this, and then you're going to attach the m plus 169. So this is going to turn into 78m plus 169 plus 9m squared. Okay, there's our final result. Again, I always like to go through and verify with the area model so you can see another alternate way to do this problem, which is just as valid. So you really do get to pick the way you like the best. And again, we're going to recall that this is the same as 3m plus 13 times the quantity 3m plus 13. and that's how we're going to execute our area model. And you can see that either way we do it, we're going to end up with the same result. But once you have this pattern memorized, it becomes very easy to do this in your head. All right, let's take a look at our third and last example. In this example, we're going to continue doing the same thing. Identify your example as a binomial squared, so it fits this pattern. Our a is going to be 5a, and again, be careful because we have a variable a, so just be aware of that. And our b is going to be 7b. So in this problem, we have both an a and a b, but again, this is just kind of our template that we're using to get our result. So we're going to take our a squared plus 2ab plus our b squared, and we're going to plug in our a and our b. So we're going to put 5a in the first spot, 5a goes here, and then 7b goes in the last two spots. All right, now it's just a matter of multiplying things out. So we have 25a squared plus 2 times 5 is 10 times 7 is 70, and then we have an ab plus 49b squared, and we are done. So that really is how quick this shortcut works. But again, because we like to verify things and make sure we're on the right path, let's go ahead and do our area model. I'll zip through that quickly for you. Okay, and after zipping through that, you can see at this point, this is a little bit less work. If you have this pattern memorized, it will save you some time. But if you're more comfortable using the area model, there's nothing wrong with that. That will work every time as long as you don't make a goofy mistake. I hope this video helped you to understand how to use this special product pattern.